Right now, if you stood outside for 6 hours with no hat, no sunscreen, no shade, and no water bottle, your skin would blister, your brain would start to cook, and by hour 4, you'd probably be lying down somewhere involuntarily. Now imagine doing that every single day, not as a punishment, as Tuesday. That was life for early humans on the open savanna, under a sun with no ozone hole to complain about, but also no SPF 50, no sunglasses, and no air conditioning waiting for them at home. Nobody thinks to ask this question because the sun doesn't look dangerous. It doesn't have teeth. It doesn't stalk you through tall grass. It just sits there, doing what it's always done, quietly cooking every exposed piece of skin on the planet. But the sun killed ancient humans constantly, slowly, invisibly, in ways that never make it into the documentaries about lions and mammoths. Heat stroke, dehydration, skin damage that turned into infection. Sunburn so severe it disabled a hunter for a week in an environment where a week of not hunting could mean starvation. This is the threat nobody talks about, and it's exactly why we need to. Let's establish how bad it actually was, because hot day doesn't cover it. Early humans evolved and spent most of their history in equatorial and subtropical Africa, some of the most intensely sun-exposed environments on Earth. UV index values in these regions regularly peak at levels considered extreme by modern measurement standards. Add open, largely treeless savanna terrain, and you get direct, unfiltered solar exposure for the majority of daylight hours for an animal that, unlike almost every other mammal around it, was losing its fur. That last detail matters more than people realize. Nearly every other large mammal on the savanna, lions, antelope, elephants, has a coat. Fur is many things: insulation, camouflage, protection. Humans lost almost all of it. On paper, that's a catastrophic design flaw for an animal living in one of the sunniest places on the planet. Bare skin exposed directly to the sun for 8, 10, 12 hours a day should have been an evolutionary dead end. Except it wasn't. And the reason is that losing fur wasn't a mistake. It was a trade. Here's what almost nobody talks about. Fur loss and sun survival are the same story, not two separate ones. The trade was heat management. Humans are, pound for pound, one of the best cooling systems in the entire animal kingdom. We sweat. Not the way a dog pants or a cat licks itself, but through eccrine glands spread across nearly the entire body, up to 2 to 4 million of them. When sweat evaporates off bare skin, it pulls heat away from the body directly and efficiently. Fur would have trapped that moisture, turned every sweat gland into a wasted effort. So evolution made a calculated bet. Lose the fur, gain the ability to shed heat fast enough to stay active in conditions that would put a lion or a wolf into forced rest by midday. This is why persistence hunting worked. This is why early humans could move, forage, and travel during the hottest hours when most predators were resting in whatever shade they could find. The brutal sun wasn't just a threat to survive. It became a tool, an advantage, a window of time when humans could operate and their biggest competitors couldn't. But losing fur came with a cost, and that cost was the skin itself. Bare skin under constant UV exposure needed its own defense, and the defense was pigmentation. Populations that evolved in high UV equatorial regions developed deeply melanated skin, and this wasn't cosmetic. Melanin is a genuinely effective natural sunscreen, absorbing and scattering UV radiation before it can damage the DNA in skin cells. Populations with high melanin concentration in high UV environments show measurably lower rates of UV-related skin damage and skin cancer than lighter-skinned populations in the same conditions. This adaptation likely emerged early and strongly in human evolutionary history, essentially as fast as fur loss made it necessary. The body solved the sun problem from the inside before it ever had a single piece of technology to solve it from the outside. Now let's talk about behavior, because biology only gets you so far, and ancient humans clearly knew it. Timing was the first and most obvious lever they had. Anthropologists studying modern hunter-gatherer societies in hot climates, groups like the Hadza of Tanzania or traditional communities in the Kalahari, consistently observe the same daily rhythm: intense activity in the early morning and late afternoon, and a long, deliberate rest period during the hottest hours of midday. This isn't laziness. It's thermoregulation dressed up as culture. Sit still, find shade, conserve water, wait out the worst of the heat, then resume. This pattern shows up again and again across unrelated hot climate societies on different continents, which strongly suggests it isn't a cultural quirk. It's an inherited survival algorithm, refined over hundreds of thousands of years and still running in human behavior today, usually labeled as a siesta and treated like a lifestyle choice rather than what it actually is, ancient risk management. Shade wasn't passive either. Ancient humans actively sought and engineered it. Natural shade from trees and rock overhangs shaped where groups traveled and camped, the same way we saw with rain, shelter, and predator defense in other survival contexts. But there's evidence of something more deliberate, too. Simple constructed shade structures, branches and hides angled to block direct sun, appear early in the archaeological and ethnographic record. This wasn't shelter from weather in the storm sense. It was a calculated tool against a slower, quieter killer. Here's where it gets genuinely interesting. Clothing, the same technology that protected ancient humans from cold, also protected them from the sun, and in hot climates, that relationship flips in a way people don't expect. In many traditional desert and savanna societies, the instinct isn't to strip down in extreme heat. It's the opposite. Loose, lightweight, breathable coverage worn specifically to block direct solar radiation while still allowing airflow and sweat evaporation underneath. Bedouin and other desert-adapted cultures have used flowing, layered garments for exactly this purpose for generations. Counterintuitively, more fabric, worn correctly, can mean less heat absorbed directly into the skin and less water loss to evaporation from direct sun contact. Ancient humans in intensely sun-exposed environments almost certainly arrived at some version of this principle long before it had a name. Water management was the other pillar, and it's the one most people underestimate. Dehydration under sun exposure doesn't announce itself dramatically. It creeps. A person can be losing dangerous amounts of fluid and functional capacity well before they feel what we'd call thirsty. Ancient humans, without any of this explained to them in a textbook, appear to have developed sophisticated water source knowledge passed down exactly the way landscape knowledge was passed down in other survival domains. Memorized locations of seasonal water, digging techniques for accessing underground water in dry riverbeds, knowledge of which plants store usable moisture. The Sand people of the Kalahari are a well-documented example, capable of locating and extracting water from sources that would be completely invisible to an untrained observer. Using accumulated generational knowledge of a landscape most modern people would consider a death sentence. There's also a detail that rarely gets mentioned: eye protection. Prolonged exposure to intense sunlight and its glare, particularly reflected glare off pale sand, water, or in some regions, snow and ice, causes real and cumulative eye damage. We saw earlier, in cold climate survival, that ancient humans in snow environments carved narrow slits into bone to cut glare, essentially inventing sunglasses. In hot, bright environments, similar principles applied. Some evidence suggests deliberate use of natural pigments and even specific hairstyles or head coverings to reduce glare and shade the eyes directly. A small detail, but one more example of ancient humans solving a problem most people assume didn't exist until modern eyewear did. Skin treatment is another piece of this puzzle that deserves more attention than it gets. Multiple traditional cultures in intensely sun-exposed environments developed the practice of applying natural substances directly to the skin, specific clays, ochre, plant oils, and animal fats, for reasons that were partly ritual, partly cosmetic, and partly, very plausibly, functional sun protection. Ochre in particular has documented use stretching back over 100,000 years across multiple sites in Africa, and while its symbolic and ritual significance is well established, some researchers have proposed that it may also have offered a genuine physical barrier against UV exposure, not unlike a very early form of sunscreen. The full picture here is still debated, but the pattern, mineral-based skin applications appearing specifically in high sun environments across unrelated cultures, is hard to dismiss as coincidence. Before we zoom out, there's a physiological detail worth pausing on, because it's the kind of thing that sounds minor until you actually think about what it means. Heat stroke isn't a modern gym injury. It's a core temperature failure, and it kills fast once it starts. When the human body can no longer cool itself effectively, core temperature climbs past the point where enzymes and proteins function correctly and organ systems begin to fail, sometimes within a single afternoon. For an ancient human, this wasn't an abstract medical risk. It was a real and present danger built into the act of simply existing outdoors during the wrong hours. And the fact that our species developed one of the most efficient cooling systems in the entire animal kingdom, again, up to 4 million sweat glands, more than almost any other mammal on the planet, tells you exactly how intense the evolutionary pressure from heat actually was. This wasn't a minor optimization. It was survival infrastructure built directly into human skin. There's also a social dimension to sun survival that almost never gets discussed, and it mirrors something we've seen in other survival contexts. Groups didn't just individually manage heat, they managed it collectively. Anthropological observation of hot climate hunter-gatherer societies shows coordinated group behavior around the hottest parts of the day. Shared shade spaces, communal rest periods, and often specific roles for who ventured out during peak heat to check on water sources or livestock while others conserved energy. Children and the elderly, the most heat-vulnerable members of any group, were consistently kept in the coolest, most protected positions available, whether that meant the deepest shade, the inside of a shelter, or simply surrounded by other bodies that could shield them from direct sun. This wasn't formalized policy. It was accumulated, practical wisdom, the kind that gets transmitted the same way fire tending and water finding knowledge did, through direct teaching and generational repetition, because the groups that didn't figure this out didn't get to pass anything down at all. Diet played a quieter but real role too. Sustained heat exposure increases the body's need for both water and specific electrolytes lost through heavy sweating. Traditional diets in hot climate societies often include foods and preparation methods that happen to support this need. Certain wild plants and animal sources naturally higher in sodium and potassium, consumed instinctively or through generational trial and error long before anyone understood the underlying biochemistry. This is a pattern we've seen again and again across ancient human survival strategies. Nobody needed to understand the mechanism to correctly identify the solution. Generations of careful observation. Does this food make people feel better after a hot day? Does this behavior reduce collapse and illness? Functioned as a slow, brutal, but genuinely effective research process run continuously across thousands of years and an uncountable number of individual lives. Let's zoom out, because there's a bigger pattern hiding underneath all of these individual adaptations. Every single strategy we've talked about, timing activity around the sun,